beginning. All right, right from the beginning. So just remember everything. So what we're looking at in terms of organic chemistry are hydrocarbons. They are made from hydrogen and carbon. That's where the word comes from. Hydrocarbon. Hydrogen makes one bond, carbon makes four bonds. I'm not going to go to the periodic table again and show you why, because that's nice to know, but in terms of what we're doing, we're looking at the structure of the organic molecules that you're going to be looking at. The simplest of the organic molecules that we can build, this is like Lego. It is Lego for grown-ups. And I have friends who do things like organic chemistry and all they do is play around with shapes and problem solve. And I think that's a really good, fun kind of thing to be doing for the rest of your natural life. Let's pick a nice colour. So I might go for like a purpley colour. I quite like purple. Purple's a nice colour. We looked at the fact that you can string different numbers of carbons together. So what we've really got is within hydrocarbons, carbon bonded to hydrogen. Carbon has four bonds, and that's where we're going to start. And we start with one carbon. And the simplest group to look at is alkanes. We're going to have a look at them. I'm going to go through quite fast because we've done these about 2 times. So when something's got one carbon, it starts with the prefix meth. So meth means I have an organic molecule, but it's only got one carbon. There's meth. Eth means 2. Prop means 3. 4 means bute. So I remember as me, PB, you'll get used to the names. Methane, ethane, propane, butane. Butane, 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay, so if I've got 1 carbon, it's got 4 bonds. I've got to draw 4 lines on it. And it was really funny. I was doing an organic chemistry with the year 13 yesterday. And we couldn't work out why, and I'm very cheeky about this. The hardest thing about organic chemistry is counting to 4. And it sounds really condescending. I'm not being condescending, so we sat there. It was about 9:30 last night. I was teaching till about 9:30. And we thinking, why is this not adding up? And we had carbons with 3 bonds on. And we just didn't see it. We just didn't recognize it. So our numbers didn't add up because we couldn't count to 4. So as much as I'm kind of being cheeky about that, the hardest part about this is ensuring you count to 4. So I've got 1 carbon and 4 bonds around it. So I'm going to have a hydrogen here, a hydrogen here, a hydrogen here. And hydrogens only form 1 bond. So this is methane, 1 carbon, 4 bonds around it and 4 hydrogens. If I write this in shorthand, I've got 1 carbon with 4 hydrogens. Unlike maths, you don't put the 4 before the H, you put a little subscript and 4 like that. Okay. Next, we had ethane, which is 2 carbons, and this is the last alkane I'm going to do. You make sure every carbon has 4 bonds. You pop on the hydrogen. This is ethane. All right. Okay. So that's covering all of that. Well, hey, done. Ethane. What comes after in terms of, this is called a homologous series. Don't worry about it. I'm just throwing words out. You'll pick this up as all languages the more you talk about it. So the next homologous series, alkenes. These contain a double bond. Well, you can't have a methene. The reason being, I got a carbon. I can't have a double bond to a hydrogen. Hydrogens only have 1 bond. I can't do that. That's just wrong. So the smallest you could get is ethane. 2 carbons, a double bond between it. Now remember, you're counting to 4. 1, 2, 3, 4. Now if you look very carefully, every carbon has 4 bonds. This is ethene. If I was to draw propene, it would be 3 bonds. One error students make is they go, oh, look, double bond, double bond. No. When we look at double bonds, we only put 1 double bond in. Now I've got to count. 1, 2, 3, 4. So this carbon here, 1, 2, 3, 4. And the last one, 1, 2, 3, 4. And pop hydrogens on every bond that's sticking out. This is propene. Prop, because it's 3 carbons. Propene. And you've got to get used to it. So we did that last week. This week, we're looking at the alcohol homologous group, or homologous series. Homologous series. Alcohols. There are many, many types of alcohols. These are actually easy to draw. The functional group, the bit of them that's important, is called an OH group. And you'll see what I mean. It's an oxygen bound to a hydrogen. Now, we've got to be very careful how we draw this. There's a shorthand word that I draw, which is all right, but not very good at GCSE. The smallest one will contain one carbon. All right. Now, I'm going to put 4 bonds around it. 1, 2, 3, 4. One of them has to be OH. This changes this into an alcohol. Now, if you draw it like this, it's all well and good, but if we ask for like a displayed formula in an exam, we'll go, oh, no, that's wrong. And the reason we don't like that is the way you actually want to draw this is like this, O and H. Okay, this is your OH group, your alcohol group. All right. Now, like all things, this is drawing. You're just getting used to it. This is one carbon, so it starts with meth. MePB, that I wrote back there. Meth is one carbon. So that's meth. It's an alcohol. So this will call methanol. This is what you can go into a DIY store, what they call B&Q, Wix, whatever you want to call it. Yeah, the little one down the corner from your house. This is paint stripper or white spirit. It's for cleaning. All right, you can't drink this. It's poisonous. So there's more than one alcohol. So when we turn around and talk about alcoholic drinks, we're talking about one particular alcohol. And the alcohol we're talking about when it comes to alcoholic drinks is ethanol. Eth is the prefix for 2. So we'll have 2 carbons. So we go carbon, carbon. We drop all our bonds in it. 1, 2, 3, 4. 1, 2, 3, 4. Everything is a hydrogen except for one. And I always keep it on my right-hand side just because I have it, but it's really helpful at A level to have them in a given position. Dash, dash. That's ethanol. All right? And that's how you draw ethanol. So today, you've got a couple of tasks to do. All right? Now, it starts off with, oh, did I not put it on? Oh, that's terrible. I thought I put that sheet on. Did I not download that sheet? Oh, yes, I did. I just didn't put it onto the board. Okay. So, what we've got here, if we kind of look very carefully, in this first worksheet, all you got to do is name them. Now, these look really strange, but all you're doing is counting the number of carbons. All right? That's it. All right? Now, I don't really want you to bother with the position of this. You'll see what I mean later on. We're not looking at position, what called position isomers. We're not looking at today. All right. So I'm going to pick one. Dun, dun, dun. C4H10O. C4 for carbons. This would be butanol. Butanol. Well, why? Well, if you remember, but if you're new, you also realise that we have this naming convention. I'm actually going to bring it up from... well, I'm just going to write it out. So I wrote it here. MePB, methane, ethane, propane, butane. So M, let's do it neatly because it was here, but it really doesn't matter. I'm going to write it here. So, how I remember which one's which, MePB, right? 1, 2, 3, 4. There's 4 carbons, it's B. And what those letters stand for is meth, eth, prop, and but, right? And you've got to learn them. That's really the truth of that. So here, hey, calm down. I don't care what it is. Shh. So here, you got 4 carbons. 1, 2, 3, 4. B is but. So it's butanol. Oi, cut it out. I'm trying to teach. You cheeky monkey. Don't care if it's a cat. Butanol. But, 4 carbons. B, but. There we go. Anol. All alcohols end in anol. So 1 carbon. Methanol. Ethanol. Propanol. Butanol. Let's put that on the end there. Let's put the butanol so you can see. All right. So your job today, monkeys, is to name them and draw them. If you finish, if you finish, I've left work on from last time as well, you can then draw alkenes and name them, and that'll be fun. All right, let me just stop recording 10 minutes. Oh!